Okay, welcome. My name is Samuel. So I want to talk about our new product, which is Sinus board 3.0. So we have designed this system, and there are some unique features of the inverter that I want to talk about. I want to talk about its fast feedback. I want to also talk about the waveform is quite sinusoidal in nature. Want to do, we also talk about the charging, also talk about the fast changeover, and some other protection that is there. So we also have a pin reserved for in case you have to shut down the inverter using external circuit. That's a fast shutdown pin. We have used we have dedicated a pin on the microcontroller to that. So there are also other features that we will be seeing as we are going to test the inverter. So moreover, this we want to talk about this our card. Once you buy the card, you can't use it with lower version. Like if you purchase the card with the IC, you can't use it on lower versions of our Sinus board. So it's only for 3.0 that the IC has been programmed for. So now we are going to check the system to see how it functions. Thank you very much. Okay, so over here is the inverter card. So you can see it's still the same shape with other cards that we have, like the 2.4 and 2.3 and down. So but there is a very big there are changes in the card. So it's not the same controller we are using, and moreover we have added some unique features in the sense that the charger can work as low as 120 volts to still be charging. Also talk about the signal control we are using. We are using the polar SPWM signal, two particular switching frequencies, 23 kilohertz and 20 kilohertz, as the case may be. So here is our calibration button, and here is the screen. So I'm going to turn on the inverter. If the inverter uses a push button, so here is the push button, and here is our battery. We have connected it. So and we're going to power on the inverter. So there's light in the office powering this our office here. So you can see the inverter is running, and here is the display. That's the battery, AC output. I don't know whether I can get it. AC output. That's the load percentage. We also have shows Samsonictechs pure sine wave system. This is the default setting. So when you buy the card, it comes with our name, which you can change at will. So as you buy the card, you can decide to change the name. You understand? You can decide to change the name to any name you want. So I'm going to show you how to enter setup. So here is my calibration button, and I'm going to press the OK button. Once I press the OK button, we enter calibration setup mode. So I press OK button. So here is the calibration setup. So this is battery setting. In case you want to set the battery to match what is on the reading on this, we have already done that. Assuming your battery is 12.8, but when you read it with your meter, it's showing 13.0. So you come here to increase to 13.0. Once you click OK, you save. But in our own case, the battery is 12.8. Click OK to save. Once you click OK, it comes to the next parameter, and you have the freedom to move either forward or backward. You select any parameter you want to work on. You see, we can choose any of them. We can skip to any one we want to set. So here is battery full, is set at 13.8 because this is a 12 volt system. So we move to the next one. Here is output volts. Now you use this to calculate to set the output of the inverter. Press OK. So you have already set it to 220. So we leave that. So we go to the next one. I want to show you the company name. This load setting. So assuming you want to know the load present in our office we are using 16 watts, so we just have some few energy bulbs, and that's it. As we increase the load, assuming I turn on the fan now, you see the load comes up. You can see the load to show that there's a presence of load present, so it's very sensitive. So we turn it back off. So we go to the next function, which is the maximum load. We set the maximum load is like so since this is a 1.2 kVA inverter, we set the maximum load to, let's leave it at 1000 watts. We click OK, so it saves. So here is mains input. There is no mains present, we are not going to set that one. Here is load setting. The next is maximum load. We've done that. We have charging current. By default, the charging current is 8.6. So if you don't have the clamp meter, you are not advised to enter this setup. So the next function is company name. So this company name, once you press OK, you enter company name setting. You can decide to change the company name. You see, as I use the up and down button, I move the character I move to the next character. So assuming I want to change this C to K, I click OK. Once I'm in that position, this arrow sign comes up. Then I can increment the character to my desired alphabet. I click OK. So one thing I want to tell you also is that it's not just character. We have numbers. We also have alphabets. We have symbols. So you can choose anyone you want and save and change the company name. The good thing is that once you change it, it's stored in the memory of the system. You want to give a gap here. So after Z is gap, you press OK. Then you go to the last row to exit. So we have Samsonic inverter there. So to exit, you press OK. You press OK twice, it exits. So to press up to exit the setup. Once you press up, you are out of the setup. So you come to the normal way the inverter is working. So you can see how unique the system is. So we want to also talk about the next thing we are going to check now is the output waveform and test with various loops. So here, here is this is oscilloscope and this is the output waveform. You can see we have wired it up to the to our connector here, which is also from the output of an inverter. This is the clean waveform. You can see that the waveform is very sinusoidal. You can see, and also what we want to talk about is also how fast the feedback is. You can see this is the output waveform as at now, and we are going to turn on various loads. So this is a drilling machine. This is a drilling machine here that is rated 710 watts. So we are going to power it on. So let's check how the output waveform is going to be. See, the waveform is 90%. There's no change, and the feedback is 90%. So the feedback is very fast. That's one thing I want to say about it. Its response, fast response to load and removal of load. Now this is another drilling machine we have here. That's 750 watts. 750 watts. We are going to test it. Okay. So now let's check. What we are after is the feedback, the response to the feedback, how fast it is.